What's up? Yeah, this one's pretty easy, honestly. I didn't do it before, but it's just fun center mass. But yeah, so I think this might more be more of like a lecture than like an actual like video song problem. But yeah, I'm gonna do it anyway, I guess. So find the center of mass of a 1 kilogram particle at blank, a 1 kilogram particle at blank, and a 2 kilogram particle at blank. Whatever this is, not blank, but like whatever the hell that. I don't want to read it out. So yeah, what is the center of mass? So basically, when it's saying find the center of mass, it wants the center of mass coordinate. So xcm, ycm. Okay, how do we find these? So the center of mass for the x, right? It's gonna be m1 x1 plus m2 x2 plus dot 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 and x and all over. I think it's the sum of the masses. M1 plus M2 plus dot 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 and yeah. So this is the formula, and basically what people like to say, they say, oh, this is the center of mass is like the weighted sum of everything. I never really got it. It's kind of like how people say that the derivative is an instantaneous rate of change, which is also kind of a oxymoron. But yeah, I never really got it, but I just memorized it by formula. Uh-oh. Yeah. So weighted average sum, whatever. Okay. It can't be this difficult. But yeah, I guess a way to visualize it, you can go like here, let's say we have many points here. I really like this diagram specifically. I don't know if this is in the book or I saw this in a different Everaise, no, in a different physics book. But yeah, I really like this diagram, and this is gonna M1, X1, M2, X2, M3, X3. I don't know why I liked it. I think I just liked it. But yeah, oh no, these should not be X's, by the way. We only use X when it's purely on the horizontal. These should be R's. R's are position vectors. Yeah. So yeah, let's just find the XCM. So the XCM will be so it's M1 times X. And oh yeah, I need to cover YCM. YCM is the same thing, by the way. Instead of it being the X coordinate, it'll be the Y coordinate. So Y1 plus 2 Y2 dot 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 all over 1 plus 2 dot dot dot. Okay, yeah, it's the same thing. So center mass at 1 kg particle at 0, 0. So for axiom, 1 multiplied by 0 is 0, 1 multiplied by 0 is 0. So both x, so for the first term, right, both of them will be 0. Um oh, also, by the way, I think you should start with denominator. Yeah, so the denominator is where you just sum all the masses. You can just see 1 plus 1 plus 2 is 4. So yeah, the first term is 0. This one will be, let's say this is the XCM formula, right? M1, X1 is 0 because this point is 0, anything times 0 is 0. Now, M, M1, M2, which is 1, times 1 is 1, and for Y 0 as well. And this one's going to be plus 2, right? Because you multiply 3 or 4. Okay, I get that my explanation is really bad, but this should be the main thing. I'm really just plugging it into this equation. And it should be the same thing for the other one, YCM. So it's all over 4. And the first one is 0. The second term is 0. The third term is 2. So it's equals 1/2. So yeah, the answer is this. Yeah, so basically what I did is I identified x1, 0, x2, 1, x3, 1. I identified y1, 0, y2, 0, y3, 1. And I found masses. I applied these two formulas and I solved for the center of mass. Yeah, that should be about it. Yeah, this was a pretty simple problem, actually. Yeah. So yeah, I'll see y'all. Bye.